Imagine this for a second. You're told that solving this incredibly complex, seemingly impossible mathematical puzzle requires the world's most advanced quantum computer, right? We're talking millions upon millions of dollars, sub-zero cooling systems, and physics that honestly kinda border on magic. But then, imagine a researcher casually walks in, opens up an ordinary laptop, the kind that, let's be honest, might be struggling to just run 15 browser tabs right now. They run a program, and boom, they solve that exact same problem. Sounds completely impossible, right? Well, welcome to this explainer, because in 2026, this actually happened, and it absolutely stunned the scientific community.
Okay, let's dive into this because it really feels like a classic locked room mystery. On one hand, you have quantum computing. This is incredibly expensive hardware, mind-bending mechanics, the absolute cutting edge of human engineering. And on the other hand, you just have standard, everyday tech. For years, the entire computing world just assumed that these massive computational problems were strictly 100% off-limits for classical computers. And yet, this 2026 breakthrough just completely shattered that wall using nothing but a standard laptop.
So naturally, the very second this news dropped, this massive, echoing question rippled through the entire tech world. Is the quantum revolution over before it even really began? Are these multi-million-dollar machines suddenly, totally overrated? To actually solve this mystery and figure out if quantum is obsolete, we have to look under the hood at the mechanics of what just happened.
All right, Section 1, the foundation, bits versus qubits.
And this brilliantly illustrates the basic difference we've all probably heard about by now. Traditional computers rely on bits, which are just billions of sequential binary decisions, ones and zeros. But as you know, qubits operate on quantum mechanics, meaning they can actually represent multiple states simultaneously. This totally wild concept of superposition is exactly why experts assumed qubits would just permanently dominate these complex problems, because they can explore vast landscapes of possibilities all at once, rather than having to painstakingly check them one by one.
Moving on to Section 2, the quantum-only problem.
To really grasp the sheer scale of the task they were doing in 2026, think about it like this. Imagine you're looking for one specific, entirely unique grain of sand, and it's hidden somewhere on literally every single beach on planet Earth. A classical computer has to use brute force. It's essentially walking down the beach, picking up and checking one grain of sand at a time. It is incredibly inefficient. A quantum computer, though, it searches all the beaches at once. And that right there is why the experts assumed this specific type of mathematical optimization task would just permanently remain way beyond the reach of standard silicon chips.
Okay, Section 3, how a standard laptop solved it.
Now, what's really interesting about this slide is how the researchers in 2026 pulled this off. They didn't artificially supercharge the laptop's hardware, and they didn't invent some secret futuristic microchip. Instead, they just completely rethought the approach. Think about it like a giant maze. Brute force blindly runs down every single path, smashing into dead ends until it eventually stumbles upon the exit. But algorithmic intelligence, it recognizes the hidden mathematical patterns in the maze's actual design and just calmly walks straight to the exit. They both reach the destination, sure, but one uses pure smarts instead of raw, unadulterated power.
And that right there is the big secret to our 2026 mystery. The breakthrough was purely 100% software innovation. By writing a profoundly smarter mathematical algorithm, the researchers basically just bypassed the need for all that raw, simultaneous processing power of quantum hardware. It was just a massive, undeniable victory for human intelligence.
Which brings us right back to the most logical, frankly, urgent question the scientific community faced immediately after this specific algorithm was published. If we can literally just write smarter software for our everyday laptops, does this mean quantum computing is dead?
Absolutely not. No way. We need to immediately debunk that massive misconception right now. What this 2026 event actually taught researchers is that some specific problems we just blindly assumed required quantum hardware, actually have highly efficient classical solutions that we just hadn't discovered yet. But listen, one successful classical algorithm does not just magically erase decades of intense quantum research, nor does it solve every computational nightmare out there. Because there are still highly complex arenas where quantum computing holds massive, totally indispensable potential. We are talking about life-changing fields here, simulating molecular structures to rapidly discover life-saving drugs, engineering entirely new atomic materials, running hyper-complex climate models to literally help save our planet. Add in massive financial optimization and global logistics. These are tasks with so many moving parts and variables that classical algorithms simply can't touch them yet. So no, quantum computing is far from dead. Its focus has really just become a lot sharper.
Section 4. The power of software innovation.
Let's move to and see how this builds on what we already know, because this 2026 event actually fits perfectly into a much larger historical pattern: software dramatically amplifying existing hardware. Think about things like compression algorithms that suddenly allowed us to send massive files over terribly slow internet connections, or artificial intelligence using incredible math to perform absolute feats on standard everyday silicon chips. Search engines, cloud computing, all these monumental shifts succeeded because smarter algorithms made the hardware we already had exponentially more powerful. The laptop breakthrough, it's really just the newest chapter in that exact same story.
Finally, Section 5, the hybrid computing future.
So the crucial point is, we are heading straight into this incredible era of hybrid computing. It's a highly cooperative model. And what that means is we'll be using classical computers to solve exactly what they are uniquely efficient at, while seamlessly handing off the truly impossible, mind-bending simulations over to the quantum machines. By working in tandem like this, these two approaches are going to accelerate scientific discovery far beyond what either system could ever hope to achieve on its own.
Which leaves us with a pretty fascinating reality to chew on. Did an ordinary laptop completely replace quantum computers? No, but it served as this incredibly powerful reminder: never, ever underestimate human creativity. Because sometimes the biggest breakthrough isn't actually a brand new machine, but just a smarter way to use the ones sitting right there on our desks. So as computing evolves into this new hybrid era, I want to leave you with this final thought. Will the future of our technological progress belong to those who just build faster processors, or will it belong to those who dream up better ideas?